Hi students, today we are tackling a really interesting organic reaction from JEE Main 2024. This question is all about cyanide nucleophile substitution, but the trick lies in carbocation stabilization. So let's decode this reaction step by step. So here you can see that this is the reaction from JEE Main 2024 as per this question. So we are given this substrate which react with potassium cyanide in alcoholic solution under heating which produce major product B. So here you can see that there are four options are given. Let's solve together to find the correct option for this substitution reaction. Let's analyze the question first. So this is our question. So here you can see that they given potassium cyanide in alcoholic solution. So potassium cyanide usually reacts by substitution reaction. Here cyanide ion act as a strong nucleophile and in alcoholic medium. So the reaction often allows or follows SN1 reaction if the carbocation is stable enough. So here you can see that this substrate, here bromine atom, so act as a leaving group. Here potassium cyanide act as a strong nucleophile. So therefore this reaction is SN1 reaction. Here when bromine atom leaves, so we form the carbocation, especially in this carbon. So now the big question, who stabilized this carbocation? Some students think the phenyl group helps by resonance, but careful, this carbocation is not a benzylic carbocation. It is one carbon away from the ring. So the phenyl cannot directly stabilize it. On the other hand, here you can see that one methoxy group is directly attached to this carbocation. So now you can see that oxygen has lone pair of electron that can effectively overlap with MTP orbital and stabilize it strongly. So this makes that this carbocation at this carbon quite stable without any rearrangement. Since here some students can think like that. For example, so when you shift this methyl group by rearrangement, so resulting that new carbocation could generate this particular carbon. The new carbocation is now benzylic carbocation. So that carbocation is stable enough. However, carbocation is quite stable. Therefore, here no rearrangement takes place at all. So now you can see that this lone pair of electron moves here. So resulting that generation of this new intermediate. So because this oxygen lone pair of electron moves towards this carbon, therefore now oxygen get positive charge. Now our cyanide nucleophile, which is a strong nucleophile that readily attacks this carbon atom. So now this pi electron move towards the oxygen atom since oxygen has positive charge. So resulting that generation of this substitution product. So here the important point is this methoxy group stabilize this carbocation by lone pair tonation. So therefore here no rearrangement takes place. So therefore cyanide directly attacks this carbon, so resulting the generation of this substitution product. Let's moving to our question. As per our discussion, among the four answers, the correct option for this question is option 4. So that's how we crack this tricky question. So remember, always check which group can actually stabilize the carbocation center and don't get trapped by the word of phenyl. unless the carbocation is directly benzylic. So if you found this video helpful, hit the like button and share it with your friends. And don't forget to subscribe ChemOrgChem for more smart tricky questions like that. And see you in the next video. Bye bye.